Andariki namaskaramuలు. Namo Namaha. Today is second day of our Vedic mathematics by Gautham Mukherjee. We will start with Vande Mataram and Prarthana. After that, we will request him to continue his lecture yesterday. Let us start with Vande Mataram by Challachitra.
Vande Mataram, Vande Mataram, Sujalam, Sufalam, Malayajasitalam, Sasyasyaamalam Mataram, Vande Mataram. Subrajosna pulakitayaminim pullakusumita drumadala shobhinim suhasinim sumadhurabhashinim sukhadam varadam mataram Vande Mataram Vande Mataram. Namaskar.
Vande Mataram. ధన్యవాదములండి చల్లా చిట్బాబు గారు. Now let us request Satya ji to recite Prarthana, please.
Sure. Namaskaram andarki. Let's do meditation for a minute. Gananam tva ganapatigam havamahe kavim kavimnam upamasravastamam jeshtarajam brahmanaspata anasrunvannotibhis siddhasadanam. Om Shri Mahaganadhipataye Namaha. Om Prano Devi Saraswati Vajebhirvajinivati Dhinamavitriyavatu. Om Shri Mahasaraswatyai Namaha. Gurureva gati gurumeva bhaje gurunaiva sahasmi namo gurave. Na guroh paramam chesirasmi guroh matirasti guroh mama pahi guroh. Jnananandamayam devam nirmalaspatikakrutim adharam sarva vidyanam hayagrivam upasmahe sruti smruti purananam alayam karunalayam namami bhagavatpada shankaram lokashankaram shankaram shankaracharyam keshavam badarayanam Sutra Bhashya Kruto Vande Bhagavantau Punah Punah Ishvaro Gururatmeti Murti Bheda Vibhagine Vyomavad Vyapta Dehaya Dakshina Murtaye Namaha. Asato ma sadgamaya tamaso ma jyotirgamaya mrityorma amrutam gamaya. Om Shanti Shanti Shanti. Matrudevo Bhava Pitrudevo Bhava Acharya Devo Bhava Atithi Devo Bhava. Om Sahana Vavatu Sahanau Bhunaktu सह वीर्यं करवावहै तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः। श्री गुरुभ्यो नमः। हरिः ॐ।
బాబు గారు మీరు మ్యూట్ లో ఉన్నారు.
Yeah. So let us request Gautham ji to start the webinar, please.
Some problem I not 1 minute. More options to share. Since my screen got more and to share, and this can be all in this. Increase.
We are able to see the screen. Go ahead.
Yeah. Yesterday we are discussing about this one we have crossed. We did here a base. This one sub base. Actually, yesterday we did below and above a base, and then multiplication near a base above, and before that it was below. Below was there. This was starting of the below. The two examples were there. There two, then above were the two screens with different lengths, and the explanation was given. Then the mixed kind of thing was there, and the involved was the vinculum and how to, after clearing the vinculum, what happens. This was discussed. Now, any other general, this explanation was given. Now, any other general, to some extent, we can, many of them, we can do the sub-base. And according to the relation of the sub-base with the base, we have to either divide it by or multiply by some number, which is the ratio of that sub-base to base, and we get the result. So that was the yesterday I discussed about below. Now I designed two more with above a sub-base. It's similar to the previous one, is only it was below and it is above. This thing is procedure becomes same, and then again a mixed kind where one is above a sub-base, is 500 was the sub-base here, another is below. So then again that involved is the vinculum, the negative number, and then after dividing it 245, and then finally when I clear the vinculum, we get the same answer. This is also shown here. Now this also we discussed. This a sub-base can be, well, 250 can be made a sub-base. Similarly, I thought that even I request all the participants can put their own problem, say around 300. Something is below 300 and something is above 300. Or say above 400 even. So one of them will be 100 something. doesn't matter. It will be a convenient sub-base can be always chosen, and then that can be worked with, and any problem comes, you can refer to me, or you can show me in your through WhatsApp. It's possible that I can show you that what is the correct one. Of course, the result always you can check by your calculator or the conventional method. So this was also discussed that a half remains becomes the value 50, half in hundreds place. So the expression with a factor means sub-base factor, how it modifies is also was shown. Now today I come to more general multiplication. Any question? Today I come to more general multiplication. It's called Tiljog method. Normally what we do, suppose we get a 2-digit number by 2-digit number. What I do, first we multiply by 5. You write in the first line, and then by multiply by 2 and put the second line, but one children are asked to mark the unit digit with a cross, isn't it? And it means that we are going to shift it towards left, and that is equivalent to, because this is 20 plus 5. So 5 we will multiply with, then you have to multiply by 20. So, but we multiply by 2 and put a cross on the unit digit. So that equivalent to multiply by 10. So it becomes multiply by 20. But here in the Tiljog method, what is done? All the unit digit coming out of this, all the tens digit, all the 100 digit coming out of this expression are put together, bunched together. Not that we first multiply by unit digit by all the digits of the one multiplicand. But one multiplicand's unit digit will not straight away multiply all the digits of the another multiplicand. So here we do such a way by permutation combination of this is shown here. The Urdhva Tirjogabhyam, actually full word is Urdhva Tirjogabhyam. Upper and then slant. You see that cross, the straight way. So this is straight, 3 into 5, put 5 here. 3 into 5, put 15, 5 here, and 1 we put towards left here as a carry. Then the next one is 4 into 5 plus 3 into 2. It cross 4 into 5, this like this cross. 4 into 5, 3 into 2. 4 into 5, 3 into 2. Becomes 26. The 6 is put here, 2 is here. And again 4 into 2 is 8. So it straight comes here. And thereafter, unit digits will be written here in this row and carries are written in the below. And the final answer becomes this one by adding this. So this grouping, you see the algebraic expression, it is like this. Now come to another example, bigger number, 3 by 3. So here, 2 by 2, 3 by 3. So 100, so 2 numbers. This is not ABC and PQR, but 100A plus 10B plus C, like this, 314. And then 100P plus 10Q plus R, like 352. How it is done? But in 10,000 digits will come from here, 1,000 digits will come from here, 100 digits will come from here, 10 digits will come from here, and finally unit digits will come from multiplication of these two, and then we add. So it is like this. So straight, both ways there are straights, then there are 2 at a time, like this cross. The 3 at a time, then again extreme to extreme, extreme to extreme, middle to middle. So here, how it will happen? 3 into 2. Yes, we can write. Even here, there is no difference between doing from left to right or right to left. You can also very nicely you can do from left to right as well. See, 3 into 3 is the first digit, 9. Then comes 3 into 5 plus 3 into 1. This into is 18. 8 we put here. and 1 we put here. Then 3 into 2 plus 4 into 3 plus 1 into 5. 23. 3 is here and 2 is here. 23. Then comes the next digit. This is called tens digit. 1 into 2 plus 4 into 5. So this is 1 into 2, 22. So this is 22 here, 2 here. And finally, 4 into 2, the state one. 4 into 2 is 8. And then you can do it as this way, or these are all independent numbers. You can put in any fashion you can do. And whatever you do, you have to place it in a proper place in which it is 10,000th place or 1,000th place or 100th place, 10th place or units place. You have to do accordingly, place it accordingly. Always put the carry actually carry a extra weightage of 10 times of that number. So what is the whatever be the weightage of 8 here, the weightage of 1 comes more than 1 more 10. For example, here it is 1,000th digits, but this 1 is carrying in the 10,000th. Similarly, this 10th digit, this is 10th digit 2, but this is not in 10th digit. This will be 100th digit. So it will be carry. This carry of this coming out of this calculation will have a better, will have a higher value. So we will put it in the below and down with a left, so that finally we add, carries are add, and then 100%. Any question? Any confusion?
Yeah, you should react. Otherwise, we can't move forward. Please, people should react.
No, sir, this is clear.
As I told, we change the algebra and our procedure gets changed. Since childhood, we are taught to first multiply 2 with this one, put here, then multiply 5 with this one, first multiplicand, and put left below, and 3 with that, finally add. So it is not the procedure. The algebra has been changed. We regroup these all numbers, procedures, all expression, expressions coming out of the numbers. We regroup them to sort out what are coming from highest digit to lowest digit, and of course carry will have a higher value. So you put it left down, and then we finally add. So you give another example of higher this thing, 5 by 5. Here also it is like this. That leftmost this is 2 into 3 is 6, and left but 1 is this one, 2 into 5 plus 3 into 3, 19, 9 is here, 1 is here. That way it goes. Actually, same example in the next slide, I put in a sparse manner. So to make it clear, so 1 into 2 is 2 here. Now this intermediate, see, something is always below this. Below this will come from this, like this, and which is in between these two digits. Because I wrote in a sparse manner, it becomes very clear. 3 into 2 plus 1 into 4 is 10. 1 is here, 0 is here, 1 is here. 4 into 2 plus 1 into 6 plus 3 into 4 is 26. 6 is here, 2 is here. So it is systematically put below this thing, or either middle of the digit or below the digits, so that to make it clear. You can just see it. And then the application of vinculum. Here, see, so many carries are coming. But when the same problem, it is 56 and 356, I made it 4 vinculum, 4 vinculum. It's 44 vinculum. And that way, you have to always mind it here, which is negative also. So by that process, it becomes only the 2 carries are coming. Only 2 carries are coming. Instead of 1, 2, 3, 4, 5, 6, 7 carries, only 2 carries are coming, because some of them are getting cancelled. So it will make it this particular add and then get it then, and then when we clear the vinculum, we arrive at the same result. Is it clear? My PowerPoint presentation are shared, so you can try this one, and you can similarly do similar things. Now I do comparison between multiplication methods. I'll come back if required. I'm continuing discussing on the Urdhva Tirjagabham method. Urdhva and Tirjagabham means upper straight as well as slant. 889 multiplied by 898. So 8 into 9 is 72, 2 here and 7 here. 8 into 8 plus 9 into 9. If you add it, it becomes 145. So 5 here, 4 here, 1 here. Okay. Then 8 into 9, 8 into 8 plus 9, 8 into 8 plus 9 into 9, because 145. Now, 8 into 8 plus 9 into 8 plus 8 into 9 becomes 208. So 208, 208. See, it is in hundreds digits it is carrying. 8 into 9 plus 8 into 8. It is actually 136. Then it is no point in writing it because it is nothing is there. So 136 it would be here. 8 into 8, 64. You can put this way also. When you approach to us left, you can do some shortcut like this. Then you add and comes to very big numbers with a lot of text. But same question, if you first convert into vinculums, 889 convert into vinculum 1 and 111, all this, vinculum. 898 becomes 1 and 102 on vinculum. So 1 into 2, minus 1 into minus 2 is positive 2. Minus 1 into 2 is again positive 2 plus this is 0, positive 2. Minus 1 into minus 2 is 2. Minus 1 into minus 1 is 1. So 2 plus 1 is 3. Plus this 3 is there. Now 1 into minus 2 is minus 2. 1 into minus 1 is minus 1. Total minus 3. And then becomes minus 3 and minus 3. And this becomes 0 and this becomes 1 into plus 1. Minus 3 plus 1, minus 2. Minus 2 is put here. 1 into 0. Then 1 into minus 1 is minus 1. Minus 1 into minus 1 is 1. We put it 0. And 1 into minus 1 is minus 1. And 1 into minus 1 is minus 1. We put it 2 minus 1, minus 2. And then 1 into 1 is 1. And when this is vinculum is cleared, this 2 is to do, say, this nichilum, this is reduced to 0. And then 9 minus 2 is 7. 9 minus 0 is 9. And 10 minus 2 is 8. We cleared the vinculum. And 3, 2, 2, of course, remains unaffected. So we arrive in the same result. My nichilum navatas charamang dasata 889 becomes my minus 111. And 898, it becomes minus 102. 889 minus 102 becomes 787. Or 898 minus 111 is 787. This into this becomes 11322. How it comes? Now 111 again I put, it is above 100, 1100 above 100 is 2 above 100. This is 111 plus 2 is 113, or 102 plus 11 is 113. 11 into 2 is 22. So 11322. So this 1 becomes carry. So add that 7986. Now, considering this, can anyone tell which this particular problem becomes the easiest?
Nikhilam Navata.
Nikhilam Navata. That's what I told. When you have multiple methods at your hand, you will not be forced to conventional method. I also put this is not this is also not conventional method. Now also I put conventional method. Conventional method, you do like this. See, big numbers, and you add this conventional method. Conventional, but using vinculum. This is also a new another method can be there. So we do conventional to multiply -2 with this. The sign changes. See 2 only vinculum. This 0, of course, no. So therefore, I shifted 2. Here, I shifted 2 places. Here, this is shifted 2 places because this 0 I didn't write here. 0 line. -1, so sign changes, and 1, all sign remains. And then finally, we add them, we arrive at the same result. This is conventional. Even in conventional method, if you use vinculum, what is the result of that? I have shown here. So now you compare 1, 2, 3. Oh, sorry. 1, 2, 3, 4, and 5. 5 methods. Totally. Somebody else, anybody else can come give him comment, which is the best one. So what I want to tell that depending upon the number of the given the problem at hand, the numbers that is playing the role here in the particular problem, you can choose your method. And by practicing over, say now we have become aged and we do not put so much effort on mathematics. Now, had it been suppose put in the course of preliminary this 7, 8, 9, not exactly, this is not fit for some of them are not fit for say class 3, 4 or something like that. So class 5, 6, 7, 8 and so on, depending upon the kind of course. If we introduce there, and these children will have will develop a intuition that depending upon the problem at hand, which is the best method for doing a particular working out a particular solution. Is it clear? That was my. We need any clarification for any of these slides, previous slides?
So one question, can I ask now?
Please.
This Nikhilam Navata method, if the numbers are far off from the base, then as you can see in your example also, 111 multiplied by 102 came up. So you had to do a second round of the same method, right?
Yes.
So when the numbers are, as you have mentioned, that the numbers have to be close to the base. And whenever we get sub base also, it is 500, 750, 250. Yesterday I tried one method by which I took a sub base as 700 and it worked out correctly, but then the complexity increases because you have to multiply it by 7 by 10 to the answer on the left side. So,
yeah, 7 by 10
way the complexity, that way the complexity increases if the numbers are not close to the base.
7 actually is not a factor, so better you choose there 100 as a base and multiply by 7. So instead of multiply by 7 by 10, can do, no problem, because you have become at the time more mathematically more competent and expert. So you can try your all experiences.
Right.
Whatever be the present knowledge of mathematics, you can easily, you will be better person to judge, but you can even using this the idea of these methods, you can even create new methods. That is the most beauty of these things. Please.
My question is this Urdhva Tiryagabhyam method. Both the numbers you have taken of equal size, like 3 digits. So it doesn't matter if it is 3 digits and 2 digits also.
Not at all that matters. So you can try it. I can see here. I mean, actually, this example that we have taken, both of the same nature, 315. doesn't matter. If I suppose 314 by 852, it will work in the same fashion. It will work in the same fashion. It is also here also, these are all small. Actually, this is
You just
the first class, so therefore I kept it small,
correct,
small because
correct.
just to understand.
If it is a smaller number, you can add zeros and make it equal size, and then
Exactly. Yes.
Okay.
So
I got it.
have a lot of flexibility that way. So here it doesn't matter whether something is 0 and suddenly this becomes 8. Suppose becomes 8, 5. What we do here? We put 1 and 2 vinculum. Okay.
Correct.
Suppose this becomes 8, and this, so 8 we don't want to keep, so it becomes 2 vinculum and 1 here. It will increase the length, and again you do 6 by 6 digits. If you put a 0 here, that way that flexibility is there.
Yeah. Okay, sir. Thank you.
Yeah. So, so you practice more so that this becomes very easy to this thing. So 8, 8, 9 I put here. I could have put 1 as you told. I could have put 1 less. But these are to show the extremities, that how much difficulty we face for this kind of examples in school like this, and then what are the solution even in that conventional method, and then if we use Uddhati Jagabham, what happens without vinculum, with vinculum, and finally Nikhilum method, and these things with 2 steps. Now this is with a comparison of mathematical algebra, multiplication algebra. So far we have comparison of some examples, but algebra. Given 2 3-digit numbers, this and this, the conventional method performs this way. As I told, this also I discussed actually. This is written on the top first line. Then this is written on the second line with place shift left. That means multiplied by 10. This is this into this written in the third line. I put a further 10 multiplied by 100 because the 100 is there. 100. So this is R into this one, and then 10Q and 10Q into the whole one. 10Q, Q, and then shift towards left. 100P into this one. So we put the P into this, and then shift to means that 100 function is there. Then all added. However, in the Urdu Tirjagabham, this is done this 10,000 AP plus, already you have to put 1,000, this thing, 10, 100, 10, and this thing. Units are written on the top line, carries load. Now this is important. Tirjag method has been proved to be more efficient through research, more efficient, energy efficient. I've written, I've seen a paper, in the last probably time permits, I will discuss on that, but no, this is not a part of the course. But you want to know actually, some people told that why we learn Vedic mathematics, our calculation is, calculator is, we always use calculator, even we do not learn any method, we'll be using calculators. I found a boy, when I asked him what is 25 into 25 divided by 25, he was taking out calculator. I asked him 25 into 25 divided by 25. So why it is calculated? He will look at the expression, no, first. That is 25 multiplied and divided again. The answer will be 25. So instead of that, so too much dependency on the equipment. That is number one. Secondly, if this is Tirjagabham is more efficient, and you know any device, I'm using the computer, using the mobile, even displaying a particular pixel. So this is black and this is white. Even to display it, there is a lot of calculation involved all the time. Now, in the background, if the computer is making an inefficient calculation, then the energy will be more. If, on the contrary, if the computer uses a more efficient method like this in multiplication process, the thousands of multiplication all the time is happening, and billions of devices throughout the world. So the energy that will be shaped will be in not in kilowatt. It may go easily to megawatt, more than megawatts. So that's what actually that may be the the persons. The answer of the persons to the persons that what will be the use of Vedic mathematics will be this one. It will shape energy. Okay, I came slightly off the way. Now, since multiplication is over, I came to division method. Now, division, the conventional division, how to do? We do some trial and error, and then we do these things. But Nikhila method of the division, again, it is a near sum base. So we start with 9. So you have to do 34 divided by 9. Now, if 34 is divided by 10, so 4 will be my remainder, and 3 will be my quotient. But this 9 is 1 less than our base, means 10. So each of 10's digit will contribute 1. So therefore, this out of 3 is contributed, and this I add, so it becomes my, because of that 3 extra contributed, my remainder gets changed here, and we get 3 as quotient and 7 as remainder. Isn't it? 34 divided by 9 is this one. Oh, first of all, I wanted to forgot to tell you this. This Nikhila method division is not going up to the fraction level. It is going to only to find out the quotient and remainder. Purpose of division is to find quotient and remainder on any given dividend and divisor. So this dividend is 34, divisor is 9, and this is the quotient. I mean, this is the quotient, and this is the remainder. This is answer. Similarly, I come to another example. 61 divided by 9. So had it been divided by 10, 1 is remainder, 6 is my quotient. Put a division, a demarcation line, and then for each of these deficiency in 1, so 6 will be contributed here, and then it will be similarly here actually it is this one, this 12. So it will contribute one more in quotient itself. So this is 123 by 9. This is actually 123 by 9. So this again, had it been divided by 10, so it will be this one, 12 and 3 here. It will be contributed to 1, and 3 will be contributed to us remainder, and 1 will be contributed to us quotient. So 13 becomes quotient and 6 becomes remainder. 253 divided by 9. So because of these 2 here, this becomes contributed. This 2 gets contributed here, and 2 gets contributed here, and then it's then it's added 5 and 2. 2 plus 1 is 3 here. 5 plus 2 is 7, and then again we add this 3 plus 7 is 10, and then 25 plus 2 is 27. This 10, and again get 1 more is contributed towards quotient. So that gets added here and becomes 28 quotient and 1 remainder. Actually, it is put in one line. So there is a method in one line, but you can put it. Any confusion in this?
They want it to be explained again.
So these are small numbers, no problem. Here, understanding. This is put down directly here, because each of these tens digit will contribute. But here it comes in tens digit for 100 digit, to start with 100 digit. This 100th digit will put 1 here. Will contribute 1 in the 10th digit. And then total 10th digit becomes 3. That 3 gets contributed towards remainder. There are two steps. You see, there are only 1 step here. There are 2 steps here. Then finally we add. Similarly here, this 2 in 100 digit will contribute 2 in the 10th digit. Total 10th digit becomes 7. This 7 gets contributed towards remainder. This will make 10 as remainder, 27 as quotient, and 10 as remainder. But dividing by 9, 10 cannot be remainder. So it will contribute 1 more towards remainder, and 1 gets contributed towards. Only 1 remains in the remainder. In the remainder, only 1 remains. And the out of 10, the quotient here gets added to the quotient, and because total quotient becomes 28. I come to more examples. It will be, see here, for bigger numbers. In 1 line, actually, the example is given such that even 1 line do not have much complication. In fact, in a practical field, you may have more bigger numbers, and you have more kind of this thing. So 1, 2, 3, 1, 2 divided by 9. So 1, 2, 3, 1, 2 divided by 10 is 1, 2, 3, 1 is quotient and 2 is remainder. But it's a 1 shot. So 1 will contribute to the next. Suppose the weightage I told you, you need 10, 100, 1,000, 10,000. So any x place will contribute towards the x minus 1, one lower. So this is 10,000 place will contribute 1 more, same kind of things more towards the next one, 1,000 digits. 1,000 digits. So this becomes 1,000 digit will be increased. 1,000 digits will increase. The 2 plus 1 is again becomes 3 here. The 3 plus 3 becomes 6. 6 plus 1 is 7. Finally, because this is total contribution, now finally you have to add. What was supposed to be divided by 10 is like this in the top. And the contribution, because the effect of this 1 is coming gradually below, like this. And finally you have to add. So this is again final adding is there. And this was 9. 9 cannot be remainder. So we contribute 1 more and remainder is 0. It's clear? So,
Yeah, go ahead, sir.
okay. 1, the bigger. So this 1 contributes to the next digit like this. 2 plus 1, 3. 3 plus 0 is 3. 3 plus 0 is 3. 3 plus 2 is 5. 5 plus 1 is 6. And finally you add. These are the coming from the original one, which is divided by 10. And this is the difference that was created by dividing by 9. So we have to add these things. Finally again. So this is again divided by 10 is like this. This is the coming out of 1, 1. 0 plus 1 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 6 is 9. 9 plus 4 is 13. 13 you in total, do not write 1 here and 3 here. Final thing is, everything is in remainder. So that makes it 22 as remainder. And these are all as a quotient. And then, again this 22 we divide, becomes 2 and 4, means 2 remainder, 4. 2 into 9 plus 4 is 22. So this becomes 4 as equal. This 2 is a quotient and 4 as remainder. So this 2 quotient gets added with this whole thing. Gets final quotient becomes this one, 112405, and then 4 remains as remainder. Here. This is about 9. So similarly, we divide by 8, 7, 6. Gradually, it becomes more complicated, and we finally arrive at the point that the Mukherjee method is not efficient. And this Mukherjee method is most efficient. The closest it division by a number closer to tens, power of 10. 23 divided by 8. So 23 divided by 10 is 2 and 3. 2 quotient, 3 remainder. Here it is too short. So this 2, each tens digit will contribute 2 here. Instead of 1, earlier it was 1. So 1 was added. Here is 2. The same thing is repeated with 2. 2 into 2 is 4. 4 plus 3 is 7. So 2 and 7. 3. 3 into 2 is 6. 1 into 6. 3 and 7. Divided by 7. 7 is deficiency from 10 is 3. So 1 into 3. So here 1 and 5. 3 to 6. 2 remainder 6. So 1 and 4 is 1, 5. 23 divided 234 divided by 8. What happens? Now 23 remainder 4 remainder 23 quotient with 10. So 2 into 2 is 4. 3 plus 4 is 7. This 7 in the tens digit will contribute. 7 into 2 is 14 in the remainder. So 14 becomes, total remainder becomes 18 and quotient becomes 17. But 18 remainder cannot happen with 8. So it becomes 2 more is added. This you can do by conventional also, whatever you feel like. 18 you can easily see that this is 2 more contributing and 1, 2 as a remainder. Or otherwise 1 and 8 again you can do 1, 8 like this, and then it becomes 2 and 2. So this 29 remainder, 345 and divided by 8. So 3 into 2 is 6. 6 plus 4 is 6 plus 4 is 10, and into 2 is 20. So total is 25. This is 40. But this 25 will finally contribute like this. If you do like that, or if you know it, 24. 25 means actually 3 into 8 plus 1. So 3 gets contributed towards quotient and 1 becomes remainder. Clear? Any question?
I think it's again, there is some doubt for some people. So they want to have it again repeated.
Anything in chat box?
Yeah, they say
Sorry,
that
sir,
it
I
is
was
not
here.
clear. The division is not clear.
Oh, division is
wanted-
not clear. Huh?
Yeah.
Yeah. Division is not clear. Idea is actually that I will again repeat. You know whether idea is clear or not. We always put it in that way that had it been divided by 10, what remainder and quotient we would have gotten. So put a dividing line, a separating line from these two. Then you see, because this is shortfall of the tens power, because of this shortfall, how much you are going to see here, like the conventional method, we are not doing trial and error. But the idea is that division is done once only, and that division is very easy. It is by power of 10. Division is done with power of 10 only, and then we add up the contribution, extra contribution coming out of the deficiency of that divisor, means 9 here. from 10, means nearest 10, the 10th power. We are adding the deficiencies, adding the contribution coming out of the deficiency in a positive manner. And we are adding that. That is the idea. So this is the procedure. If you keep in background of your mind, division is done once only. Here division is done. Here is the division is done. But here we are adding the contribution out of the deficiency, out of this deficiency. Then finally we add. Here. But procedure wise, 3 and put 3 here. 6, 6. 1 plus 1 plus 2. 2 plus 1 is 3. Finally add. 2 here. 2 plus 5 is 7. 7 plus 3 is 10. 10 cannot remain. So again 1 and 1. It becomes 8, 28 and 1. Procedure wise I am telling. 1 here. 2 plus 1 is 3. 3 plus 3 is 6. 1 plus 6 is 7. Finally add 1, 3, 6, 7, 9. And 9 becomes, is more than the divisor. Again, we have to do processing. Otherwise, suppose had it been 8, no further processing. 1 plus 1 here, 1. 1 plus 2 is 3. 3 plus 0 is 3 plus 3. 3 plus 5 is 3 plus 2 is 5. 1 plus 5 is 6. Add. This is coming out of the division by 10. This is coming out of the contribution. Finally, total is this. 1, put below. 1 plus 1. 1 plus 0 is 1. 1 plus 1 is 2. 2 plus 1 is 3. 3 plus 6 is 9. 9 plus 4 is 13. 13 plus 9 is 22. 1, all these things are added. And then this 22 becomes this one again, 2 and 4. So these 2 gets contributed towards the previous question, and the remainder becomes 4. What is the final remainder? See, 22 cannot remain as remainder. It is 4 will be coming as remainder, and 2 will be contributing as 9 into 2 plus 4 is 22. So 4 will remain as remainder. So it comes to 8. 8 is each 10, it will contribute 2 instead of 1 in case of 9. So 2 into 2 is 4. 2 into 3 is 6. Yes, simple one. In case of this 8. So 2 into 2 is 4. 4. 3 plus 4 is 7. 7 into 2 is 14. 3. 3 into 2 is 6. 6 plus 4 is 10. 10 into 2 is 20. Okay. Then after adding again, you because it is more than divisor, so you do it something else. So in case of 7, it is 3. So 1 into 3 is 3. Again 2 into 3 is 6. In case of 6, it is 4. But actually, as I told, more it goes away from 10, it becomes more inefficient. Other procedures have to be, therefore alternative procedures have to be taught. You practice it, it will come easily. Or you want me to give another example? You frame your own number then. You tell me what you want to do. Any more example?
The division by 8 and 7, these numbers, they wanted once more to be shown. Yeah, I think these examples, yeah. If we explain this example again, I think it will be clear.
Suppose it is, give another example. $425 divided by 8. Huh? Should I do? We
Yes,
start
sir.
with this.
42.
Okay.
We'll write 2.
So now your deficiency is 2 here. Write 2 here.
8.
8. This we write 8.
Just a minute, Gautam ji. The person who is not clear and he is saying, I am not clear. Let him answer.
Let him answer. Yes.
Please, Shastri Garu, you can answer and keep following what to do. Yeah.
You design your own problem.
MBS Shastri Garu, hope you are
Acha, first you do
following
it
this.
9. Acha, I suggest that first we do it 9. Or bigger one. With 9. Baru kurang. Acha dekho.
See, Shastri Garu and whoever it is who are putting their questions in the chat box, try to speak out. See, once you speak, then you can get the doubts clear. For example, why you are asking in the division by 8, how you are getting 2? 2 is the deficiency. The difference between 10 and 8 is 2.
Yes.
So let people ask. Oh, they can talk. Okay.
Sir,
Sir, that is also my doubt, sir. Thank you, sir, for your clearance. Why put to 2?
Oh, this one actually was being asked. I told that it is deficiency. I was about deficiency I told.
Okay, sir.
Because it is initially it was by 10 and then 9 is one deficient. I always kept telling like that. Actually, one is there. One is deficient, so this one have to work with in case of 9. In case of 9 is 1. 1 is deficient. In case of 2, it is, in case of 8, it is 2 deficient from the power of 10. Yes. So what it will be very bigger actually, because it is bigger. The district is bigger. You tell me what? 4 will.
yeah. The next step, sir.
1 is deficient, so 4 will come here. Okay.
That 4 is what actually, sir. Because 10,
4.
if you take, if you divide by 10, it becomes 40. Then you subtract 40 from 42. Is it not
No,
that way?
no. It is 1 into 4.
1 into 4. This deficiency, as I told you, just the logic didn't follow. So this is
Yeah, I didn't follow.
4256. Had it been divided by 10, so 425 would have been my quotient, and 6 would have been my remainder. Is it clear?
Yeah.
But because it is, we are not dividing by 10, we want to divide by 9, which is 1 deficient, one deficient from 10.
Correct.
So that each thousandth digit will contribute this 400 here.
Yeah.
This will contribute more 4 in the 10th digit of the quotient. This 4 plus 6, 7, 9 and becomes 11 actually. Even sometimes you put 1. Finally this 1 gets added here. I could have put here 1 and 1, but actually that will create some problem. So even this is actually, these are also a way of writing. Finally, you clear everything. And 11 is contributed here. Now 5 plus
11, sir, 11, where from it has come, sir?
Oh yeah. This 4.
No, 4 I understood. 4 I understood because you are multiplying 1 with 4. It's 4. Fine. Then 11?
Oh, no, not 11. Sorry. 11 will finally come. This 4 plus 2 is 6. Sorry, 6. Not 11.
Okay.
Finally, it will come. So 4 here. 2 plus 4 is 6. Okay.
Okay, sir.
But 5 plus 6, 11. Now 11 comes.
So as we go from left to right, you have to keep multiplying and add it. So
Yeah.
1 into
Okay.
4 plus,
Mm.
that's the first number. Second number is 1 into 4 plus 1 into 2. Third number is 1 into 4 plus 1 into 2 plus 1 into 5. That is 11.
Okay.
So 4, that is 1, 7, no, and 4. And this becomes 17. So this is 472 and 8.
So, Murthy garu, are
Sir,
you
will it
clear
be
now?
482?
Yeah,
Oh.
somewhat getting closer.
See,
I'm still getting closer. Yeah.
try to be patiently hearing what is
Yeah.
being said.
Correct, sir.
So,
I'm
here,
trying.
Do not.
Gautam ji, can I just come in
Huh?
between? Just to save your throat, that's all. So, what is being done is that 425/6. So, the first job to be done is 4 into 1. 1 is the deficiency between 10 and 9. That is 1.
Correct.
10 minus 9
Correct.
is 1. So
Right.
4 into 1 is the first number 4, which is appearing before 2.
Correct. Got
The
it.
next step is 2 plus 4 is 6, which will come before, under 5.
Okay. Okay.
5 plus 6 is 11. 11
Okay.
comes under 6. This
Under
into
6.
into 1 is always there. 2 plus 4, 6. 6 into 1
Oh,
is 6.
okay.
5 plus 6, 11. 11 into 1 is 11. So 1
Oh,
has to be always multiplied. Now
Yes.
it is only 1, so you are not finding the difference. But if the
Yes.
If you
difference,
want, you are not noticing.
right.
It.
If it is 8, the division is by 8, then the deficiency is
Exactly.
2. 10 minus 8
2.
is 2. So
Yes, sir.
you will be multiplying with 2 instead of 1.
Okay.
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 Now
Okay, sir.
you have done this addition. 4, 2
Yes.
plus 4 is 6. But then 5 plus
Yeah.
7 is 11. So 1 carried 1. So 471 is your addition. 6 plus 11 is 17. Okay.
Yeah. Yes, sir.
9 when you divide with 17,
No,
if you
this
divide by 9, if you do it
sorry,
again
sir.
the same, just
No,
please,
no.
please.
Yeah. Okay.
17, if you divide by 9 and if you follow the same procedure, you will have 8 as a remainder and 1 gets into the quotient. So 471 becomes 472. Got it? 471, which is there, it is the quotient because 17 is the remainder, 9 is bigger, smaller than 17. So you get
Good.
one more quotient. So 472
1.
and remainder becomes 8. Right.
Yeah. Okay.
Got it?
Yes,
so
sir.
follow this simple procedure into other numbers. Yeah, Gautam ji, you can go ahead.
Thank you.
Sir,
See,
excuse me, sir.
this is the beauty of the Vedic mathematics. That
Sir,
see, Colonel Babu has Chiti Babu Garu. So he did it 1 or 2 courses, and then he can now teach actually. This is so. The thing is that after you master it, you become so confident that soon you can teach another person. That is the main idea of the Vedic mathematics. These are all because actually a cultural kind of thing actually. Spread. Now, actually, if you do it bigger one, it will be more complicated, that's all. And it will take more time so that I do not have, because I have only this limited 5 days. And you can do it as a homework. You please do. What is the difference now? Please note it down as a exercise. 4256 divided by 8 and maybe 4256. No, don't do 7 by 7 or 6. Divided by 8.
Okay.
Okay. Please
Okay,
note
sir.
down 4256 divided by 8.
8.
And you tell me the answer. Okay. You can tell me the answer. How did you do? Okay.
Yeah.
Now we go ahead with more digits.
Sure.
My problem is only limitation of time. Otherwise, bigger numbers I can, bigger examples I could have done.
Yeah.
Now comes to division by 2 or more digit numbers requiring single processing. Single processing. Thing is, how do you do it? No. Okay, I put that one. '89. So it is 89 is closer to which tens power 100. And 89 is how much deficient from 100? Is 11 deficient from 100. 100 minus 89 is 100 minus 89 is 11. 11 is put here. So we have to work with 11 only. We don't have to work with 89. We don't have to give tables of 9, tables of 8, do trial and error. Division is done once, that is by 100. 111 when divided by 100 becomes, leaves 1 as quotient and 11 as remainder. Now this 11 gets multiplied with this 1 in the quotient and then contributes another 11. So finally the total remainder becomes 22 and 1. That's what I told you again. Division is done once only in the beginning. Rest, what are we doing? Rest, we are seeing the contribution from the deficiency and adding it up. So we put another example, 222 divided by 13. Divided by 87. So 87 is 13 deficient from 100, which is the nearest tens power. And had it been divided by 100, 22 as remainder and 2 as a quotient. 2 multiplied by 13 gets 26, and the 26 again contributed towards remainder. 38 total remainder and 2%. 88 is 12 is the deficiency from 100. 100 minus 88 is 12. 3 into 12 is 36. It becomes 69. 888. So it is nearest to 1000, and it is 1 on 2, 112 deficient from 1000. And had it been divided by 1000, we would have 1 as quotient and 234 as remainder. This is division is, work of division is done here, and it is finished. Only thing is that you have to add up the contribution from that deficiency. It is coming to remainder only, and then becomes like this. 789, 211 is the deficiency from 1000. Again, it gets 211 into 2. Whatever be in this digit that gets contributed towards remainder, that many has contributed to it. So had it been 1, 211 would have been contributed. It is 200 and 2000 something. So for each thousand, we are deficient by 211.
111.
Okay. Each of these 1000, because in 1000 we are getting deficiency of 102. In 2000 it becomes 211 into 2 is 422. Total contribution becomes, remainder becomes 767. It's clear? Very simple processing, very clear. This is also, digits are more, but processing is very straightforward and very logical, and there is no any lack of understanding here, this slide, so that we can.
Yeah, this is fine, sir. For me.
Division by 2 or more digits requiring multiple processing. one divided by 89. 11 is the deficiency of 89. So it is nearest is 100. 100 division of 100 is done here. Division by 100 is done here. And this 11, this is another technique. This is a technique actually. So although it is, although mathematically at this step it is not final. Finally it will be all clear. But here it is very peculiar. 1 gets contributed. Out of this 11, 11 is the deficiency. It is in the thousandth digit. And this gets contributed on the 100th digit, 1 here, and 1 in the 10th digit of the remainder. So basically, what it is going to tell you, now 1 in quotient and 10 as remainder. 10 is contributed towards remainder. Now 1 plus 1 gets 2. This becomes total 2, and 2 into 11 is 22 gets contributed. Finally, we add like this. This is written like that. Actually, there is an invisible 0 here because we put on a 10th digit. So 1 plus 2 is 3, 1 plus 1 plus 2 is 4, and 11 plus 1 is 12. We do not show the 0 here. Well, this is the procedure. Now 789 divided by 211. So here, sorry, what am I telling? 21456 divided by 789. Okay. So this is, we have to divide by 1000. So we have divided by 1000 here. Now this is 1000 minus 789 is 211. Clear?
Yeah.
Now because of this 2 in the 10,000, there is contribution like this. 4 here and 22 here. 4, this 2 gets multiplied with 211. So it becomes 422. 4 here and 22 here. But not in this digit. It starts from 100 digit and test digit. Now 4 plus 1 is 5. 5 into 211 is 1055. 1055, right, like this one clearly. 4 plus 6 plus 5 is 1. 11. 5 plus 2 plus 5. 12 plus 1 is 13. 13, 1. 4 plus 2 plus 1, 7. And this one is 1. And remainder quotient is 25. So 25 quotient and this 1735 as remainder in the first round. But now this is more than the divisor. Again, I do this multiple, as I told, multiple processing. 1731 multiplied by divided by 789. 211 is the deficiency from 1000. It is 211 gets completed. This is very simple processing. 211, 908. Again, but 942. Here you cannot do by this method. Here you do by simply by subtracting. So when 942 but minus 749 leaves 153. 942 was my remainder. And but I my divisor is 789. So here I do it. What I do when I subtract it by, it becomes 153. So this actually 942 becomes 2 and 153, and it becomes 27. Earlier we have 25, 27 and 153. This gets transformed into 27 and 153. Now bigger number. This is again I do the same thing. First divided by 1000. So the division is over here. 1000 division by 1000 is completed here. And then you have to only add up the contributions. So because of this 211, 2 is right here, 1 is right here, and 1 is I'm right here. Should be one after another we write. 2 plus 2 is 4. 4 into 211 is 844. 8 we write here, 44 we write like this. Okay. Now it's not over. Still something is left here on the quotient side. Until unless something is left on the quotient side, you have to carry out the operation. 1 plus 1 plus 8 is 10. 10 into 211, 2110. 2110. Add up all this. 6. So this gets contributed here like this. This gets contributed here. Then multiplied by this, of course, and this gets contributed here like this. And this added, this total becomes this. This when we add, so it becomes 150. Now this 3106 again divided by 789. This is 211 division, the same procedure. This 3 into this is 600, 739. It is become less, so division ends here. So these 3 gets contributed towards this 3 is contributed towards this here, and it becomes 153 as the quotient, and this as the number. So slightly I modify the numbers. This is 2 into this 422. 422. Now 3 plus 4 is 7. 7 into this one, 1477. Now, actually, this 14 I have written here because no other way. When I had it, we could have written in a sparse fashion. But actually, 14 you have to assume as if it is written on the, for the next processing, as if it is written below this. This 14 is below this. Finally, when we add 1, we add it here. But 14. So it becomes 14 plus 2 plus 16 plus 1, 17. This 17 when multiplied by 211. 17.
Gautamji, the arrow is too small. There, it's not being seen.
See. This is clear. 2 into 211 is 422. This is clear.
Yes, sir, that is clear.
This 3 plus 4 is 7. And 7 into 211. This is 3 plus 1 is 3 plus 4 is 7. 7 into 211 is 1477. Now, this 1 plus 2 plus 14 is 17. This becomes added to 1 plus 2 plus this 14 gets converted to 17, and 17 into 211 is equal to this one. Is equal to 3587. Here we add everything, 6 plus 7. This becomes, actually this is 200. This, mind it is not 2, it's 200. This is 770. All add towards everything becomes 5013. And quotient becomes 287. When I do 2 plus 4 plus 1 is 7. Now this 1 I can put here. 3 plus 4 plus 1 is 8 and 2 is 2. So 287 and now 5013 again I do 5013 divided by 789. We do like this same way. 5 into 211. This is 1055. This becomes total becomes 1065. Again 1068. This 1 plus 1068 becomes 211. Because this 211 is there here. 211 everywhere is there. So 211, 1 and 287. Then I wrote something more. Yeah. Then this 287 plus this 5. Total remainder is 287.
Plus 5 plus 1.
Plus this 5. Plus this 1. 293. This is my final quotient, and of course 279 gets my remainder. There is a final remainder we got, so that is the one. Clear? Should I erase? And again, should I erase all these writings? Should I erase?
Yeah, you can erase.
Yes.
This is one. It will come, clarification will come by practice. Longer complication. I written by, I myself wrote that this complication is longer. As we this actually I was searching, that's arrow. This is coming by control A and control P, my pointer. I don't have to come to menu. So this is my pen, and if I want to do for arrow, control A becomes arrow.
Right.
It's easy. Longer complication. Here is there some complication is there, but it is little less complication. Now we come to longer. As you are moving, as I told, the Nikhilam method, Nikhilam Navata Charamang Dasata. So when we subtract something from tens powers, the closer this thing from tens power is the less number. More and more is shift from the tens power, the deficiency becomes more, and this gives bigger and bigger. So therefore, as I gave in the comment, the best Vedic method in all these cases is a procedure called straight division, which is out of syllabus because in 5 days syllabus of this learning against straight division will not be that good. Maybe then in the month of May there will be second level course of Vedic mathematics. There we will learn this straight division. So far you understand that how the complication is. So this is 347 is deficiency from the 1000. This nearest tens power is 1000. 1000 minus 654 is 346. Nikilam Namataswara you can apply also. Therefore, it is called Nikilam. Now, division is done once, as I told. Division is done in the beginning. Afterwards, we will be adding the contributions, and final result will come. Division, unlike the conventional method, we stay to it. Always we do kind of division, multiplication, and then trial and error. There are a lot of tables of 6, tables of 9, 7, tables of 8, and so on. Not that. So here you do. So here is 3. 3 multiplied by 346 is 1038. This makes it actually 1038 13. Basically, this we have to think like that. This 10 is actually below 4. That is actually, again, I will be writing in space. I then have to write in another different slide. 14 into 346. Because 4844.
Sir, there is one question. This 1038 that we got, why are we writing 10 below 4 and 3 and then oblique 8? Can we not write 10/38?
Oh, no.
That part is not clear.
No. Actually, you have to see that what will contribute where. This 346 multiplied by 3 becomes 1038. That 8 is the contribution towards remainder, and 103 could be contribution towards the quotient.
Okay.
So you cannot write haphazardly like that.
I think that 1038, whatever we are
actually
getting.
Not 8. It is 800. When 800 will be the contribution towards. Therefore, we write like that. Not 8. 800.
So under the leftmost, under 3, even in the previous ones, I believe we have kept it vacant. So this 10 is actually going to be falling under
4.
4.
Yes.
But
Maybe
the only catch is how do we divide it is the question
3,
again.
4, 1,
Why
5,
not
6.
38 and why only 8? That the only question, as Anand was also asking, I think Anand, is if we have 1038, why do we write? Okay. 10 is under 4 and 3 is under
Exactly.
1. 3 is under 1. And whatever extra digits are there is going towards the 5, 6, 7.
5, 6, 7. But it is actually in that first digit of the remainder. Now
Yes.
again, this 10 is below 4. So
Yes.
this is 14 becomes
14.
14. 14 multiplied with this becomes 4844.
Yeah.
Okay. I think I got it. Yeah. Okay.
And 48 is again 48 plus 3 plus 1, 51.
Sir, again, this 48 should be under 3, no, sir?
Yeah. So this is so this is 48 plus 3 plus 1 is
52.
52 and then 2 remains,
multiplied
5
by
is carry.
346. 1700.
10/4.
Okay.
Sorry. 14 plus 5, 19. Correct. 492 I understood. Yeah. Okay.
Gautamji, I think we are going out of time. We can take this problem
Let us
tomorrow.
continue tomorrow.
Yeah, let's continue tomorrow. Otherwise, we cannot understand. I mean, the students cannot understand in a hurried way.
Oh, actually, yes.
I think just one more
I
suggestion. Just one
didn't
more
look at the-
suggestion.
Science, please.
Just one more suggestion. I think this the idea is that Nikhila method seems to be complicated, and that's why straight division is the solution. So maybe we can start from straight division tomorrow, because we already know that this is complicated.
As I told you, actually, I'm sorry, I never discussed this slide in my earlier classes. It came like that. So my only comment is that this Nikhilum gets complicated, so therefore this is Vedic mathematics state, and then we came to next one. Special. I will just discuss a small about special cases like this. What you do, there is a sub base. The sub base concept is more important now. What you do when 1011 is divided by 23? Tomorrow I can start with, but a little beginning I want to make. So 23 into 4 is 92. So first I divide by 92. So 92 divided by 92, 80 is the efficiency. We do the same procedure, and then we 92 we get this your 22. 10 as quotient and 91 as remainder. But instead of we are not dividing by 92, want to divide it by 23. So this quotient will become 4 times. So 40 becomes 4 times. This remainder will remain as it is remainder. Remainder will not be affected by the multiplication. But 91 was a valid remainder for 92. But 91 is not a valid remainder for 23. So this again I do 91 is again sort of divided. So becomes 22 as the quotient and 3 gets contributed towards. 22 becomes remainder and 3 gets contributed towards quotient. This part is clear. Just carry you this with you. This one.
Yeah, it's people should start thinking on this so that tomorrow they can be prepared. Yeah.
Then Paramartha method. What happens if it is above 8 power? Exactly, right. It is the same. It is a Vinkulam kind of thing, and it is although its name is not Nikhilam, but Paramartha method, but actually basically it is the same thing. Only the negatives are contributed. You do the same thing with negative. Then again it comes.
Gautamji, lot of people are finding it very difficult. It is going very, very fast. So I think we'll keep it for tomorrow. People are already saturated on their minds. Okay. No. Yeah, thank you. Babu garu.
I think he wanted to complete division today.
Oh, but 3 more are there. There are 3 more days.
No, we will do it tomorrow. Sir, we will do it tomorrow.
Yeah, sure.
Okay. We will do it tomorrow. Otherwise, people got saturated and also leaving because they have to go for some work. So now, let us request Satya ji to start the Prarthana.
स्वस्ति प्रजाभ्यः परिपालयन्तां न्यायेन मार्गेण महिषाः गोब्राह्मणेभ्यः शुभमस्तु नित्यं लोकाः समस्ताः सुखिनो भवन्तु काले वर्षतु पर्जन्यः पृथिवी सस्यशालिनी देशोऽयं क्षोभरहितो ब्राह्मणाः सन्तु निर्भयाः अपुत्राः पुत्रिणः सन्तु पौत्रिणः अधनाः सधनाः सन्तु जीवन्तु शरदां शतं सत्यं वद धर्मं चर स्वाध्यायान् मा प्रमदः सर्वे भवन्तु सुखिनः सर्वे सन्तु निरामयाः सर्वे भद्राणि पश्यन्तु मा कश्चित् दुःखभाग् भवेत् ॐ शान्ति शान्ति शान्तिः पूर्णमदः पूर्णमिदं पूर्णात् पूर्णमुदच्यते पूर्णस्य पूर्णमादाय पूर्णमेवावशिष्यते ॐ शान्ति शान्ति शान्तिः सर्वे जना सुखिनो भवन्तु लोकाः समस्ता सुखिनो भवन्तु स्वस्ति
ధన్యవాదములండి. చల్లా చిట్టిబాబు గారు జనగణమన పడతారా?
जनगणमन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंधु गुजरात मराठा द्राविड़ उत्कल बंगा विंध्य हिमाचल यमुना गंगा उच्छल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जनगण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे जय हे जय
జై హింద్. ధన్యవాదములండి.